Yeah, hi guys. I'm back after a very long time. So firstly, I wish you all a very happy Diwali and happy Govardhan Puja, happy Bhai Dooj. I hope you've had a rocking Diwali and you'll be having it in like all this whole entire weekend also. So I am back after a long time, almost a month. So I took a very interesting lecture for some postgraduates of hemato-oncology in at my institute, in the postgraduate institute where I'm working. And I found it very interesting. Their interest in the molecular basis was very evident, and I was very happy with it. So I thought, why not to share that lecture in parts with you people, since we are dealing with hematological malignancies and we are dealing with um, molecular pathology. I've trained in that. And the topic that I had been assigned was CML. Now, CML is something that will come in your course, and you should know about it. So, I will be taking like a 5 part lecture on molecular monitoring of CML, and will be dealing in depth with the molecular landscape of the disease pathogenesis. Uh, More so in CML, because as per the current WHO, and also for a long time, CML has been that one entity where molecular emission has always been very important. So, not wasting much time, CML, the molecular basis of CML is BCR-ABL translocation, that is also known as translocation 922, where, and this is a form of a reciprocal translocation where there are two chromosomes. So one part of one chromosome replaces the other part of the other chromosome, and this part will go to this plus. So this is happening between 9 and 22. So this change, this piece translocation is occurring between chromosome 9 and chromosome 22. Okay. So, in whenever you are diagnosing a case of CML, after looking at the CBC, the PS, the bone marrow done mostly in pediatric cases. Initially, the people, the clinicians were not doing bone marrow regularly in a CML, but now the European Leukemia Net, the latest 23 guidelines, they say that you should do a bone marrow, take sample from the bone marrow, and perform both molecular and cytogenetics, because there are certain translocations of BCR-ABL that are cryptic and they will be missed if you don't do the whole thing. I am going to show you why cytogenetics is being specified upon or being stressed upon by the current European Leukemia Net, and also later on you see WHO will also emphasize on this a lot. It is emphasizing because there are chances you might miss BCR-ABL by a single technique if you use it. Fine. So it's a reciprocal translocation between 9 and 22, leading to a fusion product of BCR-ABL1, which leads to uncontrolled tyrosine kinase activity, which leads to cell proliferation. So if you make a round cell, and then on the surface of the cell there are proteins, and these proteins, they are receptors on which, if supposing this is a cell and this is a receptor, a growth factor will go and attach to it, and the receptor will get stimulated and send the signal inside the cell to the nucleus to proliferate. Now when this becomes all, now this whole pathway of the receptor getting attached with a growth factor, then sending a signal to the nucleus inside, this is the nucleus, is controlled by some inhibitory and some positive mechanisms to control the cell growth. Now when there is a mutation happening in BCR-ABL, this cell growth, the signaling pathway becomes uncontrolled. Tyrosine kinase is an enzyme which helps in proliferation of the cell. So the thing that inhibits the tyrosine kinase, the BCR-ABL fusion product, when gets mutated, that is due to the BCR or the ABL protein, the inhibition of tyrosine kinase. Now when the fusion product is formed, it is not able to inhibit tyrosine kinase. And when it is not able to inhibit tyrosine kinase, cell will keep on proliferating. Okay. So, as per the current WHO as well as the ELN, there are two pathways by which you can develop a CML. Initially, the only pathway that we knew was that there is a stem cell, it undergoes a mutation. The mutation is BCR-ABL1, and you develop CML, and if there is progression of the disease, you develop blastocysts. Now the WHO and the ELN say that either It is a first time, first hit clonal proliferation where you get a BCR-ABL. There it causes a chronic phase CML. You start imatinib, but in this clonal hematopoiesis, once the treatment has started, a set of other mutations develop, which leads to a CML progressing into a blastocyst. So initially, baseline, there was no other mutation except BCR-ABL. Patient started imatinib, patient responded maybe, but later on the response went away and the patient landed up into blastocyst. So they specify that this group of mutation, P53, RUNX1, ASXL1, MECOM, if this group of mutation is seen in NGS in a case which was known case of CML with BCR-ABL, then chances of it becoming a AML are more. If this group of mutation is seen, chances of becoming an ALL is more. Another theory is that there is a person who is not clonally normal. If I analyze his bone marrow, I might get this set of mutations which are known in MDS. And yet the patient has not developed the disease. There is just a population of clonal stem cells lying dormant in the marrow. It was discovered unintentionally. This is known as CHIP, clonal hematopoiesis of indeterminate prognosis, indeterminate potential. Now, if in this cell population you develop a BCR-ABL mutation, the patient will develop CML just like in a normal person developing it, but this will progress to blast crisis faster, and again it can be an AML or a ALL. Another line in which this chip might go is either it might progress to an MPN or it might progress to some other MPN because it has a JAK2 mutation like ET, PV, PMF, or it might move into MDS. So now analysis of supposing a 60-year-old man with persistent cytopenias but no other symptom. Think about, could this be CCUS, cytopenias of undetermined significance? Or he comes with anemia, you do a marrow, there's nothing else, and you get some of these mutations. So he might give symptoms, or sometimes he might not be presenting with anything. You might think it's nutritional, mild hemoglobin is down, every platelet is normal, TLC is normal, nothing is there. Yet when you do a marrow and you send it for cytogenetics, you get this clonal population. And this might be there in me and in you also. Only thing they state is that as you age, these kind of clonal cells become more in number. That's all they say. So this is a very, very interesting thought process. So these pre-existing mutations remain detectable during remission in TKI. In contrast, for the top pathway, any additional mutations found pre-treatment become undetectable. Always remember, if something is there baseline, then in CML by NGS, if you do that test, if you do NGS in a case of CML, just to see cryptic trial, these ones, since they were present inherently even before CML happened, they'll always persist. So don't get biased by them. If they are not leading to MDS or anything, just leave them. However, in this case, if you acquire new mutations, they might go away after treatment. Okay, because they are acquired as a part and parcel of this BCR-ABL1 mutation. So the concept that okay BCR-ABL1 hai to BCR-ABL1 ही रहेगा is actually wrong. There might be the major mutation and then you might slowly acquire some minor mutations which might lead to a blast crisis or which might never lead to a blast crisis and the patient might remain in CP. Or a second scenario can be a patient had a clonal population, developed CML, yet when you follow up molecularly, you might get some other mutations with BCR-ABL1. As long as the patient is clinically fine, don't get scared by these mutations. Okay. So there's a piece of BCR-ABL on chromosome 9 and a piece of BCR on 22, and they translocate and they form a fusion product. Now I told you it's a reciprocal translocation, so something of 22 also goes and attaches to 9 over here. But this byproduct or derivative 9 is not important. This is not linked to pathogenesis. Research is still going on what this derivative 9 does. What is important is the derivative 22 and also known as the Philadelphia chromosome, and this one is responsible for causing the actual CML. Okay. This is a more chromosomal view of a more molecular view of that diagram where they show you that BCR has a minor and a major breakpoint. region. E1314 is the most common translocation fusion partner gene of BCR. You might get a new a minor, a very minor E19 break or a E1 break, and these lead to cryptic translocations, which might not be detected by normal molecular studies. And then similarly, if this is the 22, this is the 9, so in 22 it is somewhere over here. So this part has been enlarged for you. Fine. And this is exon 1 in ABL1. It is somewhere over here, and this is the part which breaks. So we get products like E1A2, E13A2, E14A2. 13 and 14 are the most important ones. 14 more so better in response than 13. And they give the byproduct, which is a protein of 210 kilodalton. 19A2, 230 kilodalton, and E1A2, 190 kilodalton. So 190 is more common in ALL. This is more common in CML. Sometimes the test does not detect all these breakpoints. You might just try to detect this. So if this is not there and this is there, it is still a CML, but you might call it BCR-ABL negative or an atypical CML. Or you might think, is it a CML? Because you have not done a test for these minor breakpoint regions. Okay. Similarly, same blown up diagram. So for today, this is the last slide where a percentage of the most common ones, the most common detected mutation E13 and 14 is like say 97% of the CML. But the smaller variations are still there and might occur in very small population, and you might miss a CML. So today, just a very brief overview. Next time I'll go in depth of cell signaling and what happens in translocations. After that, what is molecular monitoring of CML, and a very short overview of how you see it morphologically. So I hope you enjoy this. Happy Diwali again, and I will try and see you sooner than what I've done this time. So enjoy yourself, and please message me your questions if you have any. Thank you.